Assalamu alaikum warahmatullahi wabarakatuh. My name is Mirza Hashir Ahmed and I am in grade 5 from MD Elementary School. My Abdus Salam Science Fair project is Light Up the Darkness. Goal: we want to provide light to places where there is not enough or no light. The project is divided into two parts. Part 1: store electric energy from natural energy sources such as sunlight. Part 2: using stored electric energy to switch the light on when there is darkness automatically.
For Abdus Salam Science Fair this year, I have worked on the second part to automatically turn on the lights when there is darkness.
Materials. Breadboard. A breadboard is to develop circuit prototypes. You can see there are holes. These holes are used to connect LEDs, LCDs, resistors, etc. There are columns and rows of the holes. On the right side, the connectivity is shown in different colors. Black colors are connected in columns, while red and blue colors are connected in rows. Resistor. Resistors are used to control the flow of the current. The higher the resistor, the less amount of current will pass. The lower the resistor, the higher amount of current will pass. On the right side, I have given an example. Less resistance will make large amount of water flow, but more resistance will make less amount of water flow. Light emitting diode, LED. From its name, it shows that this is a diode that emits light. It has two legs. One is the longer leg, which is called anode. The other is the smaller leg, which is called the cathode. The anode is connected with the positive side, and the cathode is connected with the negative side with the resistor. Photoresistor. This is a resistor, but it is adjustable depending on the amount of light it receives. If there is low light, then the resistance is more and voltage is less. If there is high light, then resistance is lower and more voltage will pass, and the voltage that passes through can be measured from the MCU unit to give a reading of the amount of light falling on it. Liquid crystal display LCD monitor. This monitor is to show information. In our case, we will show a message if there is low light or if there is higher light. Procedure. As you can see here, the Arduino board is connected with devices on the breadboard. There are pins connected with the photoresistor to measure the amount of light, and there are pins connected with the LED to light up based on the information coming from the photoresistor. I also added an LCD monitor so that the user can see what is the status of our system. Setup. Pin mode photoresistor input. Pin mode LED pin output. LCD begin. Loop. LCD set off. LCD light monitor. Light value. Photoresistor input. If light value is less than 200, then LCD will turn on. LCD low light, else LCD turn on. LCD highlight, digital right, LED pin low. Variables and controls. Photoresistor is very sensitive to light. So if there's more resistance, then that means less light intensity. But if there's more light intensity, that means less resistance. Data and results. Light off. When the light is off from the phone, the photoresistor will see that, oh, there's no light. Then it tells the Arduino board to tell the LED to turn on, and the light monitor will show low light. But if the light's on, then the photoresistor will tell the Arduino board, which tells the LED to turn off, and the light monitor will show high light.
Conclusion. It was fun making and understanding the project. I learned lots of things about how electronical components work and how to program and connect them together to make an application. Just to reiterate, this is the second part of the complete project. Next year, I am planning to bring the first part developed and integrated into this one. I want to thank my cousin Mirza Labib Mahmood, who helped me a lot during this project.